Okay, kind of quickish one, I suppose, because it's kind of following on from previous ones. We're looking at simultaneous equations with fractions here. Okay, so just an extra layer to what we have in the previous ones. And I suppose this is partly going to come into nearly later algebra parts, but we can look at them in this case anyway. But basically, we're solving these in the same way, and the difference here is coming into really the first part, is in just ensuring that they're in the correct format. So currently, if I was looking at this example, I suppose, as one to use as an explanation, this I wouldn't say is in the correct format because I have those fractions. I have 5x over 3, y over 2, and that's not usually the format I would prefer. I would prefer it all in one line, no fractions, no kind of extra things to worry about here. So I suppose what we'll look at here is what we would need to do to get rid of those numbers there. So if I was to try and get rid of the 3 here, because it's division, a fraction, the way of getting rid of that would be to multiply by 3. So I would multiply this entire equation by 3. But if we look at the 2 then, to get rid of the 2, I would also multiply the equation by 2. And multiplying by 2 and then multiplying by 3 is going to be the same as me multiplying by 6 overall. Okay? And if we look back at the steps here, that's essentially what I'm saying in this second line here. We're looking at the lowest common denominator. So the lowest common denominator for 3 and 2 will be 6. So let's just see how exactly we would, I suppose, maneuver that one, if you like. So looking at this one here, we're going to multiply by 6 in every case here. 6 here. So 6 multiplied by 5x over 3. Because I am multiplying by 6 and then dividing by 3, that is going to really break down to the same thing as if I multiplied by 2. So I'm going to reduce that down to multiplying by 2 times 5x. So going over that again, I'm multiplying by 6 but dividing by 3. And 6 divided by 3 is 2. So therefore it's as if I multiplied it by 2. And the same thing on the next line, I'm multiplying by 6 but dividing by 2. So that's as if I multiplied by 3. So 3 times y. We can't forget of the last part here to multiply the 12 by 6 also. So after all our work, we're getting 10x minus 3y equals 72. This is, I suppose, our second equation here, if you like. So this is our second equation. So writing the two equations then, 2x minus 3y equals 24. 10x minus 3y equals 72. Okay, I suppose to solve the equation here, what we would want to do is, again, just our normal story, pick the letter that we would like to eliminate. The letter here that I might choose to eliminate might be y. I might multiply the top equation by minus 1 and then kind of adjust the equation accordingly. So that will become minus 2x plus 3y equals minus 24. And then the last equation, or the bottom equation, remaining as is, with a negative 3y 72 to get 8x equals, let's see, 72 minus 24 gives me 48. Divide both sides by 8 to get that x equals 6. Going back then to the equation, I probably in this case would lean towards the equation that they gave you as opposed to the one that we adjusted, just in case there's any mistakes. So 12 minus 3y equals 24, minus 3y equals 12, which means y equals minus 4. So x equals 6, y equals minus 4. So really the only extra layer in these questions is just going to be that elimination of the fraction there. That's going to be the only extra part that we need to consider. So I suppose we'll look at an example or two of that. Let's pick one maybe where we have a little extra to think about. So we'll look at this one here. X over 6 plus y over 10 equals 11 over 15, because this is kind of a good example for us to look at as well. So you might say to yourself, well, 6, 10 and 15, common denominator, maybe I'll multiply all three, see what number I get to. You might go 60. Okay, 6 by 10 is 60 and 15 probably does divide into 60 as well, and of course it does. We can actually go lower and aim maybe for, we'll aim for 30. Okay, we'll aim for 30. So let's have a look at that equation. So x over 6 plus y over 10 equals 11 over 15. We're going to multiply all the equations here by 30. and adjust accordingly. From what we said before, we're multiplying by 30 but dividing by 6, so that's like multiplying by 5. Essentially, we're just doing 30 divided by 6. 30 divided by 10, 3, so 3y, and 30 times 11 over 15. Again, we could do that one in the same way, or because it's all numbers, you could just multiply it out exactly. Okay, and we get our full equation there. So taking that now, 5x plus 3y equals 22, and then 2x plus 4y equals 20. So again, we're still in a little bit of a bind here, I suppose, in terms of solving the equation. We can go with either of our two letters here. It's going to make absolutely no difference. I'm going to try and eliminate x here, which I'm going to do by multiplying the bottom by minus 5 and the top by plus 2 to get 10x plus 6y equals 44, and minus 10x minus 20y equals minus 100. So that's going to give me minus 14y equals, let's see, minus 100 plus 44 minus 56. Let's hope that divides in nicely. 4. And it's a positive 4 because a minus divided by a minus. Filling that back in then to one of our equations here, I'm just going to pick the one that I can kind of clearly see there at the bottom or at the top of the screen. Filling in for y, 2x, I suppose that's the thing to be sure of as well. Make sure you fill in for the correct letter. So here I'm subtracting 16 from both sides. 2x equals 4, x equals 2. So x equals 2, writing out my answer, y equals 4, and boxing my answer. Okay, so really getting rid of these fractions, what you're looking for is that common denominator, multiplying across by that common denominator, and then making that adjustment as required at each stage there. So if you're multiplying by 6 but dividing by 3, you're really multiplying by 2 and kind of adjusting it accordingly there. And that's going to be really where the key things come in.